everyone. Thank you for coming for to our February session of Dr. Jaspersoft. I'm your host, Paul, and this is our guest speaker today is Ramesh. Today we'll be going over Jaspersoft performance tuning, mastering thread dumps, heap dumps, and JVM optimization. Here's a quick disclaimer. And here's our next Dr. Jasper session. It's always the second Thursday of every month. So our next session is March 13th, and that one will be about a web studio. It's going to be mastering subreports, tables, and working with expressions. So today's agenda will be about analyzing thread dumps, interpret heap dumps, fine-tuning your JVM memory, and troubleshooting techniques. Now I'll hand it off to Ramesh. Thank you, Ramesh.
Yeah, thanks, Paul. So, hi everyone, I'm Ramesh Mala and I'm working as a senior developer in Jaspersoft, and I have altogether like 20 plus years of experience especially in Java application development. Okay, now let me share my screen. Okay, so we'll start with the thread dump. So what is a thread dump? So basically, a thread dump is a snapshot of all the threads running within a JVM at a given time. So when we take a snapshot, it gives the entire threads which are, it shows what threads are running and those. So it's just a snapshot at a given time. It's not something like. And what about the states? And it shows like different states of the threads, like whether it's running, whether it's blocked, or it's waiting, and the methods which are it's currently executing. So it gives all those information. And why we need thread dump? We need thread dump especially for performance issues like performance bottleneck, deadlocks, or some concurrency issues. So that's why we need thread dump. Now, the next question after once we know what is thread dump is comes like how can we capture a thread dump? So there are different tools. Generally, we capture them through using JStack, which is you can use to get the thread dump, or you can use kill command with a -3 soft signal, which is basically a part of Unix-based system, where you can use this to get the thread dump. So let me show you these commands, and we will go with actual how we can generate the thread dump. So let me have this machine. So first of all, what we need a process ID of the application for which we are generating thread dump. So we can use JPS, Java process list. It gives the list of all the processes which are running, Java process which are running on this machine. I can have JPS-L to get a more better list of it. So JPS is this command comes with the JDK itself, and if you want to see which JPS, it will point to my JDK bin where it's currently located. The other option is also JCMD, which can also give you all the processes running on the same machine. You can use JCMD hyphen, it's already listed. Okay. The native way where we can use PS to get the process information also. So we can use PS-EF by grep, and we can grep for Tomcat, and we can get information about the same. So in all these three scenarios, you can see the process ID of my Tomcat is this one. Okay, so once we get the process ID, next step is to use the JStack command to get the thread dump. So I will show you.
Hey Ramesh, real quick, we have a question. Can these same commands be used on Windows as well?
Sorry, can you repeat?
Yeah, sorry. Can these commands be used on Windows as well? We have a question from one of the
Yeah. So yeah, you can use JPS, JCMD. These are part of JDK. They can be used on Linux, Windows, wherever you have installed the JDK.
Awesome.
It's available on all. Yeah.
Thank you.
So coming back to so JStack we have to use to get the thread. So this is JStack. It gives the options like to generate thread, and we have to give -L and E option to get the more. L option is for listing, which more information, and extended listing for E. So it's JStack -L-E. These are optional, but I would recommend like it's better always to get the more information. So just add these two parameters. And what was over? Let's say we have to generate threadum for this process ID. By default, if I run it, it will print the JStack on the std console. Or I can use like something, redirect it to a certain file, and I say thread dump .1.txt, and then I will have my thread dump here. So this is one way to generate the thread dump. The other option, as I mentioned, there is kill-3, which is only applicable for Linux system. Kill-3 is not applicable on Windows. For Windows, you have to use JStack. For Linux, you can use kill-3, and you can give the process ID, which was, I think again, we have to run first GPS kill-3, and we can give the process ID. So when we run kill-3, it's a soft signal to the Tomcat to generate the threadum. And by default, it will go to the std out. But for Tomcat, std out is nothing but over Catalina.out. So if I go to vim and check Catalina.out, I will have the threadum. Yeah, I have the threadum up in this. So I can copy it and use it. Okay, this is the second way. Okay, returning back to our presentation slides. Oh, sorry, not this one. Okay, so we now know how to capture this. There are other tools also available which can be used to capture this information. So I will go through them. That is JConsole and Visual VM. So let me show you the JConsole. So JConsole is also a tool available with our JDK, and it shows the list of all the JVM process which are running, and you can directly click on that process and it will attach to that process in secure connection, and we will get live information of that. And we can see the thread here. We can go to the threads and it can show you all the threads here. And we can copy these and we can share with wherever required. So that's how we can monitor our threads using JConsole. The another tool which can also be useful for generating thread dump and those is Visual VM. So in this also, once you will launch it, it will also display the same process ID, and you can go to the process and right click and you can generate thread dump. And it will show you something like this, which I have already generated. And here also we have all the information of those thread. Now, as I mentioned, like thread dump is like a snapshot. So it's always recommended to have frequent threads, especially it's like you take an interval of 5 to 10 seconds, and it should be like 2 to 3, at least 3, I would say, 3 snapshots, which will be always helpful. Instead of taking only one snapshot, it's always better to have 3 snapshots. So we can analyze it better. Now coming to the thread dump. So first of all, what it has. So it has like thread name, its ID. Thread ID is the ID which is provided by JVM, a unique identifier. Then the state of the thread, whether it's running, waiting, blocked, and the stack trace, which shows the sequence of methods for each thread. So which methods are being executed by given thread. So that information is shown in the stack. The states, as I mentioned, there are generally 5 states which are there. Runnable, when a thread is actively executing something, it's running. Waiting, when it's waiting for another thread to notify it. Blocked, when the thread is waiting blocked because of some lock it need to acquire. Time waiting, when it's waiting for a specific time, and then it will again wake up. And terminated once the thread is stops execution. That's terminated. Now this is a example of a thread dump where I have multiple threads. So first of all, this gives the name of the thread. So it depends on the developer. If they have given a very convenient name, then we can easily identify. As JVM will generate some random ID for it, which is like pool and thread. But it's always better for developers to give a good name for their threads so they can easily be identified. Second comes is the priority, where we have this particular thread as 5 priority. Then generally threads have priority from 1 to 10. 10 has the highest priority, 1 is the least, and 5 is normal priority. So this thread has normal priority. And then the OS priority, which is given by the OS. Then thread ID, which we talked already, like it's the unique identifier being provided by the JVM. Native ID is the ID which is provided by the OS. So operating system also gives some name, and this is very convenient when you have to map it to CPU usage or memory usage, then these can be useful. Then comes the state of the thread. So this is thread like in waiting, and the entire stack trace, which tells what the current thread is doing. Okay, so this. Now I will show you one example for the deadlock. So what is a deadlock? So deadlock is like a situation when 2 threads are or more threads are competing for the same resource, and they are like trying to acquire lock for each other. So in this example, I have a worker 1, a worker 2. There are 2 threads, and worker 1 has already acquired lock on resource A, and worker 2 has acquired lock on B, and worker 1 wants to now acquire lock on B, and worker 2 wants on A. So this is a deadlock situation, like they will never release it. But these are just an exemplary example. In generally, you will not find such easy deadlocks in the application, because that's a well-tested code, and it's very difficult to figure out any deadlock. Generally, it's not there because it's already well tested, but it's for example purpose. Okay, so now we know what is thread dump. So what are the best practices for thread dump panel? So first of all is like we should have always collect the thread dump mode, at least 3, as I mentioned, like 3 threads over a period of 5 or 10 seconds. Then while analyzing, look for the pattern, like look for their states deadlocked or blocked, and try to figure out for certain pattern. If they are following certain pattern, then it's easy to identify the root cause. Then always correlate with the logs. So if you are generating thread dump, also ask for the logs of the application. So you can correlate between the thread dump and the relevant logs, which are also may be helpful sometimes, because you get the method is stuck at this particular location. From logs, it may give some more ideas around. Monitor CPU and memory. Always check thread dump in conjunction with CPU and memory. Like So it's not along with the logs, also check for the performance issue, which you can get from the OS. Okay, so now let me show you one more tool relevant to the thread dump. So that is, let me go to this. So there is also multiple other tools also along with what we have seen, like JConsole and Visual VM. There is one which is very common, like fast thread, which can also give you more details information of those threads. So here I have this fast thread. I have just uploaded one thread dump here, and we will go through it. So first of all, it will show you the summary of those, how many threads are in waiting, how many are in runnable state, how many threads are in time waiting. So this gives some idea, and it shows this pie chart also. Then it groups them according to the thread pool also. So it's like Apache HTTP, which is like requesting the HTTP request, handling the, and it's like 150 threads are handling those. Then there are some blocking threads, non-blocking, which are 16. Non-blocking threads, again, under group pool P7, they are 16. And these are the thread pools. And the count is in front of us. Next, it shows the daemon and non-daemon threads. So daemon threads are, again, those threads which runs in the JVM in the background, like our GC thread, providing some resource monitoring, all those. Non-daemon threads are those threads which are actually doing the actual user work or the application work, which runs the business logic, communicate to the database, or interacts with the UI. Those threads are known as non-daemon threads. And here we have the state as showing those. Then it also shows us threads with identical stack trace. So in this case, we can see like this similar stack trace has been identified for 130 threads, and like this. So it will also categorize them based on this. We can also see the individual threads stacks here based on their different categories. Okay. Then we have these different which are CPU consumption threads, block threads. If there are certain, then we will get. Currently, we don't have. This also provides GC thread information. So currently, GC is using 10 threads, and those are the information relevant to the GC thread. And thread stack length based on their stack length. So how much, what is the size of those stacks, thread stacks? So this categorization. And it can give you, if there are certain deadlocks or those, it can predict. Currently it doesn't have, so this portion is big. But if you have a deadlock situation, then it can easily identify this. Okay. So that's all I think about thread dump analysis. Okay. Now we will go to the next topic, which is our heap dump. So what is a heap dump? To understand a heap dump, first we have to understand what is heap memory. So heap memory is the memory which JVM uses to allocate the objects and arrays. So that is heap memory. And when you say heap memory, then the question is like non-heap. What is non-heap? Non-heap memory is something which is used for method, those executions for or the class loadings, or if you are using a native library and then memory consumed by those native library, that comes under non-heap, but they're part of the process. So we have two types of memories, and today's highlight is heap memory, because we are concentrating on the heap dump, which will have objects and arrays. It's a binary. So what is heap dump? Heap dump is just the binary representation of the memory allocations. And heap dump contains live objects, dead objects, which has not referred anymore, which are like dead, and memory usage details, which size of the objects and allocation stacks. So now we have to go to the generation of heap dump. So for that purpose, we have different ways. So first of all, we have the JMap, which can be used to generate heap dump. So let me show you how to generate heap dump using JMap. So coming back to here, we have to identify the process for which we have to. So we will use same GPS, and then we can say which JMap. So it's also part of the GDK, and it's available on both Windows, Linux, and all other platforms. Now, to generate heap dump, we have to look into it. So it gives option to generate dump, which is called heap dump, and it has option to generate heap dump for by default all. If you don't specify, you can also specify live objects only, or you can by default, if you don't give the option, it will generate for all. You can specify the file where you want this dump to be generated. So we will use those options. So let's say we have JMap. Let's just run GPS again. So we have this process ID, JMap. I will say dump, and then I have to specify my file. So I will say file colon heap.bin. You can give an absolute path here. I am currently giving just the name of the file, so it will generate in the same current directory. And then we have just one more parameter, I think. What is it? The format. So we have to give format as binary. So heap dump. Okay, file name, and then we have to give the process ID, which is, let's say for Tomcat, it's this. Oh, we have given the space. Okay. What it says. File colon, okay. So it should be ideally file equal to heap. Fully this time. Yes, so it's generating the heap. Okay. So it says like the heap is generated. It gives the path of that heap and how much time it took. So let's see whether we are able to generate it. So we have the heap in, and it's of almost 1. If so, currently my Tomcat is running with no load, so it's only using the minimal memory. But in production, if your JRS is running with a heavy load, then you might have a need to generate a bigger file. So you need to consider that the machine has the sufficient space to accommodate the heap dump. Okay, so this is the way we can generate heap dump. The another option which is generally we configure is like, or which is generally required when we go the heap goes out of memory. So in that case we have to configure this parameter heap dump on out of memory. So automatically when your JVM goes out of memory, it will generate the heap dump. You can specify the path also where you want to generate the heap dump. If it's not specified, it will go to the default working directory of the VM. So in case of Tomcat, it will be, I think, tenfold. So better we specify it, as it will go to the Tomcat tenfold. Then we can talk about different tools which can be used for. So we have already seen JPS and JCMD. Now we will go through JConsole and those tools. So let me again go back to and show you the. So first if you go to the memory, it's again shows you, this is JConsole tool, which shows you the heap memory usage, and you can see again heap size here, and non-heap we have already talked about it. And it shows the information how long the JVM is up, how many objects are being, the current size of the objects. Okay, and it also shows GC information. So when it's how many objects are collected, young generation, old generation. So what is young generation here is like the young generations are those objects which are within one GC cycle collected, and those old generations are which are collected over multiple GC cycles. Those are known as old generations. And you can perform GC to reduce if it's going currently. So this is you can manually trigger it to the GC. Otherwise, it's automatically taken care by the VM. Okay, so now let's talk about the other features of the JConsole. We can also go through. So it shows memory thread. Apart from this, also it shows the class, how many class objects are being loaded, and it shows the CPU signals. You can get VM classes, which are the number of classes being loaded and those total count. You can also get the summary of the VM here through JConsole. So it clearly indicates like which virtual machine it is, how long it is up, live threads, class loaded, and VM parameters, which is what parameters has been configured for JVM. So currently these parameters are configured for JRSR. Then there is one more thing which comes with JConsole, which is MBeans. So here you can also look into what are the different MBeans being provided by Tomcat and the JRSR. So you can go to this Catalina, see the data source, and you can monitor different thread pool, the connection pools, or the JNDI connection pools. So over JRS, we have like these are the JNDI connections which we establish, and you can go to the attributes and see what's the configuration for those connection pools. Then you can also see other informations like DVCP pools informations, Hibernate informations, and Jasper server MBs which are being exposed. So this is the advantage of JConsole, where we can also see the MBs being exposed by our JRS server and in Tomcat server. Okay. Now we will go to the second tool, which is Visual VM, and we will go through the memory, this heap dump analysis. So for that also, you can just right click and generate the heap dump. Once the heap dump is generated, you can go to that heap, and it shows some basic information similar to JConsole, like those heap size, classes, instances, and environment. You can also see it's the same as JVM JVM arguments, which we already have seen. And it shows enabled modules under it, what different modules you have. Then it also shows instances and class loading, which is quite similar. But now it has some features which are not available in JConsole. Like one of them is like instance by size. So here it shows the size of each object and the instance count and their respective size. And it also has a dominator tree by retention size. So dominator is like the referencing object. So like this is referenced by how many objects, like those informations available. And you can go back to Sorry. Yeah, summary. Okay, so those are the, apart from this, the visual VM also shows us the sampler and profiler. So sampler is like it takes snapshots at a regular interval and it generates different thread dump or heap dump, and then you can sample them based on CPU and memory. In profiler, it's live, and you can also profile them according to your based on these categories like CPU and memory and others. Okay, and that's all I think for the visual web. Now let's go to the next tool, which was I want to show you, which is very useful, which is called MET or Memory Analyzer Tool. So how to get this? For this, you first of all need the Eclipse. So you can download Eclipse, and then you can add a plugin which is known as Memory Analyzer Tool, MET. And you once have that MET Memory Analyzer Tool, then you can use this. So first of all, once you have this tool installed, you can open a heap dump. So we have generated the heap dump. You can just refer it to by clicking to open it, and it will open that TD. So currently I have already 2 heap dumps opened in it, 1 and 2. So once you open it, it will show you some options like, let me close one of these. Okay, so once you will open it, it will give you the first option like leak suspect report or component report. So component means if you already sure that you have an issue with this component and you want to analyze only that component, then you can go with the component report. Else you generally go by default as leak suspect report. So I will go with, let's say, leak suspect. So it will just open it. So first of all, before going to this, let's see what it shows. So first it shows the detailed overgraph. So in which it will show a pie chart where what kind of objects we are having here and their size. So here we have like maximum objects of 87 MB, which represents to this Catalina class loader, and then we have another size which is like this object, which is it's not going. Then once you have this, you have other options to go through it. List object by outgoing reference and with incoming object. So once you have the object, you see that these objects are growing. You can see the outgoing references to it, means the objects which are referred by these, and incoming references which other objects refer to referring to this object. So this is pie chart for the biggest. Then we have the histogram. So in histogram, we get the actual details of which object is. So in this particular, this byte array has this much instance of object. It has shallow heap for this. Shallow heap is the heap which is the size of the memory for the individual object, for the object. And retained heap is the memory which is referred all the objects which this current object has the references. That is retained heap. So in case of byte, it's almost same because it's not referring. But if you go to other objects, they will have higher retained heap compared to their shallow heap. So it shows this. And the other advantage of this is like when I can compare two heap dumps. So if I have like heap dump, I have heap dump of a same DRS instance at one period when it was working fine without any issue, and the other when its memory is growing very high, then I can compare those two heap dumps. And like for example, in this case, I am comparing with this. So I can compare, and then it will show me those objects which has grown in their size. So this is very useful when you are getting out of memory. So we have a need two heap dumps one at the situation where everything is running normal, and another situation when it's almost going out of memory. And we can compare those which objects are actually growing in this case. Okay, so that's histogram. Dominator tree we already talked in Visual VM. It's quite similar. So this is exactly the same. You can see the entire hierarchy here, which objects are being referred in the nested, and rest it shows the same information, and it shows the memory percentage which is being consumed by this. Okay. Next comes to the leak suspect, which is like very useful feature of the MET. So in this particular scenario, it tells me the suspectable leakage. Where can it be? In this case, it's telling me this one scenario where I have like problem suspect one, where my mostly memory is consumed by these objects. The objects are here in these cases.
Hey, Ramesh, real quick, we do have a question. What Java version are you using? And then are there relations to special versions?
So currently I'm using Java 17 here, but there's no specific relation with the Java version. You can use any version. You can use 8, Java 8 or 11 or 17. There is nothing very specific to that. These tools are available with all Java versions.
Good to know. Thank you.
Okay, so that's so yeah. Coming back to the leak suspect, so this shows the information where gives us a hint. It may not be a real suspect leak, the real leak, but it just gives us the suspects. It may be a genuine reason where you, because this is loading Catalina class, so it's loading, so that's why it's not something but this gives some hint regarding, because these objects are growing, so we can just monitor or look into this. That's to make sure whether it's not the real culprit to grow memory. Okay, then rest I think are okay. So these were the features relevant to the memory analyzer matter. Okay. So we have talked about these tools now. So I have already covered these visually and met. There are other commercial tools also available, like YourKit or JProfiler or JClarity, IBM Heap dump analyzers, and like more. But we will not go through each of them because those are commercial and paid one. These two are something which are freely available. Okay, now let's go to the next topic, which is JVM parameter tuning. So when you look into the JVM, right, there are, I would say, nearly thousands of parameters which can be configured on the JVM side. But we will not go through all. We will go some basic parameters tuning and why we tune these parameters to get better performance, the optimal performance, right? And why tuning is important to get memory management, improved by memory management. We get better GC collection overhead. We minimize it. Like, so if you have configured a memory size of like initial memory very low, then you will have like frequent GC collection. If you increase it to very high, then there might be low. But we have to get an optimal for that. So it's always better to tune it to have, so it should not be like too much GC every you are triggering, which can causing like overhead. Then there is enhanced application startup. So again, if you have to configure in such a way that the application starts up like with a better performance, we should get a throughput and response for them. So that's why we tune those parameters. So what parameters we tune generally? So first of all comes to the memory management. So for this, there are three parameters which we generally look. There are others, but primarily these are the three. So first is the initial heap size. So this is the heap size for a JVM, which it stays to the initial, and then as required, it keeps on growing. So this is the minimal or the initial size of the heap which we need to configure. So for GRS, this is generally we 1 gig, but it still depends on the load. We can increase or decrease it. By default, I think 1 gig. And the next parameter is the max heap size. So this is the heap size till how long your heap can grow, the maximum limit. If it goes beyond this, then you will get out of memory. So in GRS, default is 6. You can configure it again to the required load. The third memory configuration is done for the thread stack. So depending on how nested calls you have in your application, more the concurrent call, then the more the nested calls, then you need a more stack size. If it is there are less nested calls, then you need lesser memory. So it's generally configured from 1 to 2 MB. In GRS, we have configured 2, which is fine. Okay. The next parameters which are required for JVM tuning is the garbage collection options. So we will talk about these three parameters relevant to the garbage collector. So by default, we use G1 GC, which is enabled garbage collector G1, and this is generally recommended for larger heap size. And this is the default for GRS. The other garbage collector option is like use parallel GC, which is very helpful when you have multi-code systems. So you can configure this when you have multi-code systems. Third is you can configure the thread count. Default, I think it has 10 threads, but you can increase or decrease based on your requirement. If it's not configured, still it will work, but it's the number of threads which are required for GC collections. Okay. So now lastly, I will talk about one more tool which can be very helpful for monitoring GRS, and that is JavaMelody. And to get JavaMelody on your system, you can just download these two jars from the GitHub link of JavaMelody and paste it in our Jasper Server Pro Web NF and then just restart the account. Just copy these two jars and restart. You will get this URL to connect it. So I have just already copied these two jars and restarted my server, and I can see JavaMelody. So in JavaMelody case, first of all, once you launch this tool, you will get the first thing is the different charts showing the different usage. So it shows memory usage, CPU usage, HTTP requests, sessions, active threads, JDBC connections, use JDBC connection, HTTP requests hitting to the server, and those errors and many more. You can get more charts also, and these are live charts. If you increase the load on the server, the charts will start in dancing. If you decrease or increase, right? So there are multiple charts available, which is very helpful for monitoring GRS. And you can see those more details also here. These shows states like stats here, stats of HTTP, stats of SQL servers, stats of JSPs, stats of errors, current requests, system informations, and threads, which we have in multiple ways. But here you can also see those details of threads here, and caches, and those all informations. Okay, so that's about the JavaMelody tool. And okay, so that's all I have. Over to you, Paul. Thank you.
Awesome. Thank you, Ramesh. We do appreciate it. Let me go ahead and Share my screen real quick. Okay, everybody. After the webinar, the YouTube video as well as these slides will be posted to our website. You can always find all our resources there. Here's some for our resource page. Let me make sure. Let me share my screen. Okay. And so any of these resources you need and everything we demonstrated today, including the demo and the tools and the software used, will be posted on the slides, and those will be posted to our website. So if you need to go back and review the video, look again, or anything like that, they will be posted there. And you can always see our YouTube channel. They're always posted there too a few days after the webinar. And then we just want to say thank you for coming to our webinars. We do appreciate it. Please engage with us. If you have any questions, concerns, comments, anything, we're active in the community. Post to our community website, log a case, email me, whichever you like. Just please engage with us. Let us know what you need. Let us know if you have any questions, concerns, comments, anything like that. Other than that, take care. Have a good day, and we'll see you next time. Thank you very much.